The mix proportioning of design mix and trial mixes. This design mix के लिए for the design mix target mean strength per mix we have to find out. I am giving this illustration based on flexural strength. It can be based on characteristic compressive strength also, but compressive strength is only suitable for only small projects. I am giving this based on flexural strength. Target mean strength of target mean flexural strength. It is FCR. FCR means target mean flexural strength at 28 days, and whereas FCR is characteristic external characteristic flexural strength at 28 days. This 2.33 I have taken. It can vary from 1.65 to 2.33. 1.65 for 1.65 for average to good, and 1.95 for good to very good, and 2.33 for very good to excellent as per IRC 15. S is standard deviation. Standard deviation, here there is no fast data of standard deviation available, fast data of tests. Hence I have taken assumed standard deviation as per IRC 44 for 4.7 for M40. It can vary from 0.35 to 0.4, but therefore flexural mean strength, it comes target mean strength comes to 4.74 or 4 either or, where F dash ER is equal to FCR plus 0.55 or FCR plus 2.33 S, whichever is more we have to take for design. So 4.74 is more, that is why I have taken, but this 0.35 is for standard deviation as per IRC 44. Every concrete is having certain amount of entrapped air to be expected in this case we are using 19 mm aggregate as per IRC table 7. It is 1% entrapped air will be there in concrete, that is why we have taken 19 mm 1% here. Selection of water cement ratio as per table 8 of IRC. Preliminary water cement ratio for OPC 43 grade is 0.28 to 0.46 for flexural strength of 4 to 5.5 mm. So for target mean strength of 4.74, the water cement ratio comes to 0.365 with the interpolation method. So but it cannot exceed maximum 0.4 water cement ratio, which is within the maximum limit. Selection of water content and chemical admixture. As per IRC 44 for 50 mm slump, if we are using 19 mm aggregates, 186 liters or water is to be used for 50 mm slump, but we have taken only 35 mm slump. So water reducing admixture 35 mm slump. So for this 35 mm slump, for every 25 mm slump 3% of water to be reduced, and also water reducing admixtures 1% we are using, it will reduce the water up to 20%. So finally the water cement ratio comes, water ratio of 0.360 and slump 35 mm, water content is approximately 182.65 liters. Using 1% admixture, water content will be 146.1 liters per cubic meter. Cement content, calculation of cement content. Cement content, it should not be less than 360 kg per cubic meters, and it should not be more than 450 kg per cubic meter as per IRC 15. So in our case, with this water cement ratio, our cement comes to 146.12, which is the water, and 0.365 the ratio, it comes to 400.33 kg per cubic meter. So after water cement content is known, estimation of coarse and fine aggregates. As per table 11 of IRC 44, volume of coarse aggregate for different zones of fine aggregates with the water cement ratio of 0.5 given in table 11. In our case, it is coming to 0.62, but our water cement ratio is only 0.35. So for other water cement ratios, as per the IRC only 0.0 for every decrease in 0.05 water cement ratio, 0.01 cubic meters of aggregates we have to decrease. With this 0.365 water cement ratio, volume of coarse aggregates comes to 0.647 cubic meters. After knowing the coarse aggregates, we can easily find out the quantity of fine aggregates. Quantity of fine aggregate, volume of fine aggregates is 1 minus 0.647, that is 0.357. So, with this mixture of coarse and fine aggregates, it should pass the grading of table 3 of IRC 44. Again, the mix proportion. The mix calculations per unit volume of concrete are as follows. Absolute volume of concrete 1 cubic meters, and after deducting volume of estimated entrapped air 1%, it comes to 0.99 cubic meters. With this volume of cement, we know that 400.33 kgs of cement we are using, and with the specific gravity of 3.15, this mass of cement comes to 0.127 cubic meters. Again, volume of water. We are using 146.12 liters of water with the specific gravity of water 1. This volume of water comes to 0.1461 cubic meters. Volume of chemical admixtures. So, we used this admixture for water reducing agent. As a water reducing agent, volume of admixture will be with the specific gravity of 1.2, it is coming to 0.00333 cubic meters. Volume of all in aggregates. Volume of all in aggregates means this total quantity 0.99 cubic meters minus complete this B, C, D, but that is volume of water, volume of cement, volume of chemical admixtures. After deducting all these, this volume of all in aggregate comes to 0.7135 cubic meters. Mass of coarse aggregates. Volume, we know that both the volume of coarse and fine aggregates 0.7135 cubic meters, and with this we know that the percentage of coarse aggregates 0.647 we earlier already determined. With the specific gravity of 2.83, it comes to 1306.42 kgs. Volume of fine aggregate, mass of fine aggregates. This again volume of fine aggregates will be 0.353% of total in all in aggregates. With the specific gravity 2.65, it comes to 667.44 kgs. Mix proportions for trial mix number 1. In SSD conditions, saturated surface dry conditions of aggregates. Cement, we found 400.33, 667, sand 667.42, but whatever we have found above, I summarized it here. Selection of mix proportions. Mix proportions for trial mix number because saturated surface dry condition aggregates naturally we not available. So, they are available in dry condition only. We have to apply correction, we have to apply water correction for this dry condition. Fine aggregates mass, this will come to with water absorption of 1%, it will come to 660.83 kg per cubic meter. In that manner also 0.8% of water absorption in coarse aggregate, it will come to 1296.05 kg per cubic meters. So, for this extra water to be added for this dry condition aggregate to become the saturated surface dry conditions, because we have designed that in saturated surface dry conditions. So, extra water to be added to dry aggregates, fine aggregates is 667.44 minus this one 6.61 kg per cubic meters, we have to add extra water. In the similar manner, we have to add 10.37 kg for coarse aggregate. So, again finally actual quantity of water required to be added is coming to 163.1 kg per cubic meter. Final mix proportions. This 400.33 kg cement, coarse aggregates 12.96.05 cubic meters, fine aggregates 660.83 cubic meters kg per cubic meters, 163.1 liters of water per cubic meter. Admixture is 4 kg, that is 1% per cubic meter. If you convert it into bags, per bag of cement, it comes to 161.8 kg of coarse aggregates, 82.53 kg of fine aggregates, 20.39 liters of water and 0.5 kg of admixture. This is for trial mix number 1 proportions, we got it. With this trial mix proportions, the slump based on trial is to be measured. If it is not coming to the required slump, again the mix proportion shall be reworked with actual water content and checked for durability requirements. 2 more trials having variation of plus or minus 10% of water cement ratio shall be carried out, and graph between the 3 water cement ratios and their corresponding strengths shall be plotted to work out the mix proportions for the given target mean strength. Minimum and maximum cement content should be the same as per the IRC. Adjustment due to higher slump requirement of RMC. If the RMC plant and the placing of concrete is far away, if the distance is more, we have to adjust the water with the required slump at the placement, and we have to be designed for more water slump at RMC plant. Thank you very much.